connect to the cloud. There we go. All right. So what do you guys do when you're presented with a challenge? There's a couple of ways to tackle each challenge, each problem. You can ignore it, which I don't know, I think everyone likes to do that, run away from it, or we can try to solve it. So problem solving is sort of like a skill, a talent, you could say. It sounds kind of weird, but it's really important. People, I know you guys don't want to hear this now, but like when you go into like college and you want to get jobs, oh my God, I'm sounding so boring right now, but it's like a really good thing to have. One of the best ways I think to develop this skill is through math, specifically competition math. I guess the competition part is only for fun. It adds aspects of solving problems, but basically we want to have a certain time limit because we want to solve problems in a certain time frame, as we want to solve them efficiently, really quickly, and we want to solve different math problems, so different levels of variability, different types of math problems. Okay, I'm gonna go really quick through these two slides. If you're in middle school, which this class is aimed for, there's two big competitions that come up during the school year. The first one is math counts. So this one is from January to like March. This is held like in different levels. So one competition is gonna be at your school, the one's gonna be at your chapter, which is like your county, then the state, and then if you're really good, then you can make it to the nationals, which is the entire US. AMC 8 is a lot more low-key. It involves the whole nation, but you're just taking it at your school. I like this one because it's 25 multiple choice. It doesn't take that long. And I'm pretty sure most middle schools offer it almost. Well, if taking this class, I assume that you'll be able to find a middle school that offers it. But if you don't, you can also reach out to me for help, because we often, middle schools without like a math thing often have a math team sponsor or a math teacher who wants to start one. All right, what we covered in this course. All right, so we're gonna cover pretty much the basics of problem solving. We're gonna have algebra, geometry, accounting, and probability, a bunch of what sounds really boring, but it's going to be really cool once we dive into those things. Problem solving strategies, some resources on your own to develop problem solving skills. We're going to use problems that are generally taken from the AMCs and math counts. Let's see. Oh, and before we dive in, I guess on the course in general, we don't have that many people here, but hopefully that'll change next week. I guess this is going to be a pretty involved class. I already asked you guys to bring a notebook, a pen, a pencil, or a pen, and an eraser. The notebook's good just because you want to use scratch paper a lot to try and write down your thoughts. Yeah, and the pencil is good for that. Let's see, anything else? Oh yeah, you're welcome to turn on your camera. That'd be really helpful because that encourages participation, engagement. But just participating in the chat is totally fine. All right, let's start with arithmetic. So arithmetic is what we call just manipulation of numbers, changing numbers in some way. We do those through these things called operations, which you guys have learned since, I don't know, I don't have a good estimate, kindergarten. Addition, subtraction, multiplication, division, and exponentiation. So as a review, addition and subtraction, that's, 1 + 1 is equal to 2. You're adding things together, combining them, or taking things away, subtracting them. In multiplication, that's what we call repeated addition. That's where you have sort of like finding the area of a rectangle. You're going to add another dimension and multiply by adding something by itself some amount of time. So 3 times 5 is 5 + 5 + 5 is equal to 15. Division is just the opposite of multiplication. So you would divide it into groups of something. Think of it like having 15 cookies and dividing among 3 friends. You're going to have 5 cookies per friend. Exponentiation is repeated multiplication, which is kind of wonky. 3 squared is just 3 times 3. You're going to multiply 3 by itself twice. I should probably be annotating. Haha. And then we're going to have PEMDAS. How many of you guys have heard of PEMDAS before in the chat or in participants? You can raise your hand or react, I think. Yes, good, Richard. And Shakira, oh, and other people, cool. PEMDAS, parentheses, exponentiation. So this is the order of operations. This is the way that we're supposed to do things. The parentheses is sort of like a human-made thing. That's what we do to indicate that something has to be done first. And then we go down the order of complexity. So exponentiation is like repeated multiplication. So we're going to get that out of the way first. And then multiplication and division are basically on the same level. And then multiplication is repeated addition. So we're going to go down that line. Okay, hope I'm making sense. All right. And now we're going to introduce a new topic maybe for you guys. So in math, we have things called variables. So variables are used to represent some kind of number, any numbers. Variables are like letters, basically. So this is where we start introducing letters into math, and then eventually you'll never see numbers. That's a lie, you'll definitely see numbers, but you won't see numbers as often after this. These are going to be something like X, Y, Z, or A, B, C. And what we want to do with problem solving is try and find what a variable is. It's like a puzzle, basically. And the most basic type of problem is going to be involving what we call an equation. So an equation is some kind of statement. Let's look at this one. X minus 7 is equal to 14. So notice that the equation has the word equal in it. In an equation, you're going to set things equal to each other, and that tells you information on how to find what a variable is. All right, in this case, X minus 7 equals 14. Does anyone already know what X is? Joyce says 21. Shakira says 21. Richard says 3. All right, the answer is going to be 21. Yeah. So what we see here is we're basically asking what number, when you subtract 7 from a number and you get 14, what is that number? All right. And one thing that's really cool with variables is you can add to each sides of an equation and isolate the variable. Oop, that's the doorbell, and someone in my family is going to handle that. Okay, when we add 7 to each side of an equation, this may sound really weird, but you're not really changing the equation at all. Because you're adding the same thing to each side, you're not changing the equal sign. So therefore, the equation stays the same. And then we just look at one side. In this case, this side, the right side is going to turn into equals 21 because 14 plus 7 is 21. On the left-hand side, X minus 7 plus 7. Just ignore the X, because we want to save that for last. X minus 7 plus 7 is going to be, well, sorry, 7 plus negative 7, or minus 7 plus 7 is just 0. So that's X plus 0, which is just X, is equal to 21. Okay, we call these equations one-step equations because you only need to do one thing to each side of the equation. Let's go down here for another example. 3x is equal to 21. When you divide both sides by 3, all right, so let's look at the left first. 3x divided by 3. Okay, this might be kind of hard to understand, but remember, 3x is just x plus x plus x. That's repeated, that's multiplication, right? So it's repeated addition. And then when you're doing dividing, you're dividing into groups again. So dividing into groups of 3, then we're going to have, 3 groups, not groups of 3. Then we're just going to have an x in each group. So x is equal to 21 divided by 3 is 7. All right. So basically in an equation, let's go back. In problem solving, there's sometimes going to be an algorithm. So a list of steps you have to follow in order to get to the right answer. So these types of problems are pretty boring because once you get the hang of it, you don't really have to learn anything more. But that's when we get into other applications of problem solving. So let's look at this side. 4x plus 7 is equal to 19. All right, and this is where we're going to do something pretty wacky. I asked about PEMDAS in the last slide because when you're solving an equation, you want to basically go backwards. That's your algorithm. You want to go this way instead. So addition and subtraction. We're going to look at 4x plus 7, and then we're going to subtract 7 from both sides. So 4x plus 7 minus 7 is 4x is equal to, and then 19 minus 7 is 12. Then we're going to go in the next area. So we're done with addition and subtraction. Now we're going to do multiplication and division. Well, there's a 4 times x is equal to 12 here. So what we need to do here is divide. So notice that in our algorithm, we're basically doing the reverse of what's already there. We had multiplication here, but we're going to divide by 4 to cancel it out. So basically, you can sort of think of these things as canceling each other out. At the end, what we want to have is just one variable, which is x is equal to 3. All right, before I move on, do we have any questions? We got time for some questions. If you're good, can you please say so in the chat? Say like I'm good, or thumbs up or something. All good. Chris is good. Richard is good. Oh, other people. Oh yeah, people are. I should probably have participants open as well. All right, we're gonna move on. Oh, we have a couple of problems. Okay, so I've been doing a lot of talking. I think now it's your turn to look at your notebook and try and write down. Well, not write down these problems. Just try and solve these problems. And when you have your answer, type it in the chat. I'm going to highlight some key phrases. And if you need help, please go ahead and ask in the chat. Do I have private chat on? Just in case. But yeah, everyone can chat publicly or privately. So if you are feeling a bit scared about typing publicly, then feel free to direct message me as well. All right, looks like everyone got the first one, 26. That's pretty good. So I don't think I have to type that out if everyone got it, but basically we want to set some variable, like let's call it x or something, when half of the students, so we take multiply by 1/2, that's going to be equal to 13. Notice the not there, like who did the 13 students who did not join. That's like, that doesn't really matter in this case because it's half. So the people who did join and the people who didn't join are either the same, but sometimes they like to throw you off like that. So we're going to multiply by 2 on both sides and we're going to get x equal to 26. All right, I'm getting some different answers for the second one though. That's a terrible 6. There we go, much better. All right, I'm going to give, actually, I don't think we have much time. Let's see. Okay, I think we've got enough people. So I'm going to explain this one since looks like all of you, I think, actually had quite a bit of time spent on this. All right, if 3x plus 7 is equal to 22, what is the value of 1 divided by, in parentheses, 3x plus 11? So what I just wrote down here is another way to describe that. With like the fraction sign, you if that's extended, that's basically a parentheses. Express your answer as a common fraction. So common fraction is just something being divided by another. No mixed numbers. Actually, they probably never ask about mixed numbers in competition math because people kind of don't like mixed numbers. All right, 3x plus 7 equals 22. There's a couple ways to solve this. The first one is we can solve for x using just this first equation. I'm going to do that pretty quickly. 3x plus 7 minus 7, so that's going to be 3x is equal to 15. So x is equal to 5. Cool. If we were to plug that in here, because they're asking us what is the value of this number, not what x is, we're going to have 1 over 3 times 5 is 15 plus 11 is 26. So we're going to get 1 over 26 as our answer. But there's an easier and a quicker way to do this. All right, this is kind of weird, but 3x plus 7 by itself can be a variable. Variables can represent basically any number. If I were to have y be equal to 22, so y is equal to 22 is equal to 3x plus 7. And I look over here, we have 1 over 3x plus 11. Well, 1 over 3x plus 11 is just 3x plus 7 plus 4. So this is equal to 1 over y, or I'm going to ignore y for a second. We're going to have 3x plus 7 in parentheses plus 4. And we know that 3x plus 7 is equal to 22. It's y. So 22 plus 4 is 26. And then right away we have 1 over 26. So a trick with problem solving is sometimes you want to try and see if there's another way to solve a problem rather than tackling it head on. Okay, and that's going to help you a lot if you were to do like some kind of timed exam or something. Multiplication and division. How are you guys feeling about this? Let's try number 5, just number 5. That should be number 4, but I took it from math counts and I didn't want to write out the fraction, so I just took the image. Let's ignore number 3. The answer to number 3 is 2, by the way, if you want to do that on your own time and check your answers. Interesting. This problem is, I'd say, yeah, well, I mean, it's a challenge problem. So if you're just learning this for the first time, then of course this is going to be pretty hard. So don't get discouraged. Don't get discouraged. Discouraged. Richard said. All right, we got 2 people for what Richard said. All right, I'm interested in time. I'm going to go ahead and start solving this problem. All right, this seems pretty weird. We got a fraction, but we also have addition in the equation. X plus 5 over x minus 2 is equal to 2 over 3. Okay, So this has like kind of a weird solution. So let's start with our basic algorithm. We want to go backwards from PEMDAS, and we want to isolate the variable so that we get the variable on one side so that we know what it's equal to. Well, right away, you can see that these are in parentheses because of the fraction symbol. So let's ignore the addition and subtraction and start with multiplication and division. We have the fraction, which means division. So in order to reverse that division, we have to multiply. So let's start on this side. On the right side, we're going to multiply by 3, which means that we have to do the same thing to the left side. I'm going to run out of room. 3 over x plus 5 is divided by x minus 2. And then on the right-hand side, the 2 over 3 times 3, trick is to just let the denominators cancel out, and then you get 2. All right. On the left-hand side, we'd still have a division, so we have to cancel that out with a multiplication by the denominator. The denominator in this case, the bottom number, is x minus 2. So if we multiply by x minus 2 on both sides, then this is going to cancel out, and we have x minus 2 over here being multiplied by 2. And now we've isolated it so that we don't have any variables in the denominators anymore. We just have what we have. What do we have? 3x plus 5, 3 times x plus 5 is equal to 2 times x minus 2. All right, we're going to do the distributive property because in parentheses, we can multiply numbers together. We get 3x plus 15 is equal to 2x minus 4. All right, and then we have x. So sorry, I'm doing this all in my head. We're going to subtract 2x from both sides so that we get x plus 15 is equal to -4. And then we're going to subtract 15 from both sides to get x is equal to -19. Yeah. All right, so I'm sorry that I went a bit quick there because there's a lot of steps, but let's see. I actually don't have to go through that much more, but if you have any questions, feel free to speak up now. If you're good, just say that you're good. We probably should have done one of these types of problems first, but basically the key is to isolate the variable. Let's write down our algorithm. We want to isolate the variable. Isolate variable. And we want to do it by positive PEMDAS. So this way from PEMDAS. Oops, pull up the chat. Oh, we have a really good question. I guess it's more of a comment than a question, but I'm going to clear all annotations. So I'm sure some of you have heard of the cross multiply method. I actually learned this too. I learned the cross multiply method first, which is look at the top and the bottom, the top of the first expression and the bottom of the next expression, and look at the bottom of the first expression, and you form this sort of like butterfly thing, or like a cross. That's why they call it cross multiply. And then you can just multiply these things together. So 3 times x plus 5 and 2 times x minus 2, and then set those equal to each other. That's technically the same thing as what we just did. If we were to multiply by 3 times x minus 2 on both sides, we would get what we have when we do cross multiplying. So I guess that's just a way to like make this easier to teach, but that's like the underlying principle behind cross multiplying. That's pretty cool. So yeah, great question. All right, systems of equations. Actually, do I have anything? Portions. Okay, we're gonna skip systems of equations for a sec. We're going to talk about proportions because I think that's more important than systems of linear equations. All right. Proportions are basically just division. They relate one quantity to another. So when we have like 5 apples and they cost 39 cents, we just divide by 39 cents. So this is what we call a direct proportion. So when one quantity increases, let's say we have 10 apples instead of 5, well, then that's going to cost, we'll multiply by 2 on the top, so we're going to multiply by 2 on the bottom. We're going to have 78 cents for 10 apples. So when one quantity increases, the other increases as well. This is basically a fraction, just division. But here's where things get a little wacky. We have something called an inverse proportion. This is the opposite. When one quantity increases, the other decreases. Let's see. Probably should have given an example of this. Let's say like 5x is equal to y. But that's not bad. Let's ignore that part. We can also call these number ratio. Okay, so I want to make sure that to get this point across, division, fractions, and ratios, proportions, they're the exact same thing. You're dividing one thing by another, you're relating one quantity to another. We're having some kind of ratio. By proportion, I mean direct proportion, by the way. All right, so an example of this is like a 10-foot pole casts an 8-foot shadow. So I'm going to use the dotted lines to represent the shadow. We have a 10-foot tall and 8-foot that's not drawn to scale. And then we have a pole that casts a 12-foot shadow. And then we want to know what this is, x. So we're saying x is the length of the pole that casts a 12-foot shadow. We're going to learn about the geometry behind this in another class, but essentially this is a proportion. We have 8/10, so we're relating one quantity to another. In this case, we're relating the length of the pole to the length of the shadow. Well, I guess in this case, length of the shadow to the length of the pole. 8/10 is going to be equal to 12/x, whatever x is. And now it's our turn to find out what that is. And we just do that by solving the equation, or we can just do cross multiplying. It's the same thing. 8x is going to be equal to 120. So x is going to be equal to 15 once you divide by 8 on both sides. So x is equal to 15 feet. Remember your units. Whoop. All right, I don't want to leave you hanging with the inverse proportion. Okay, I want to give an example of an inverse proportion. Let's say we have like some wall that we want to paint. We want to paint that wall like blue or something. I don't know, doesn't matter. We want to paint that wall and we have one person, so people. We have one person working on that paint, and if one person works on that, we're gonna take 1 day. So one people, that sounds weird, but let's just call it persons. One person is gonna take 1 day to paint that wall. But what happens when we have 2 people? When we have 2 people working, then it's gonna take a lot less time to paint that wall. As a matter of fact, it's going to take half a day instead of a full day. And this kind of intuitively makes sense, right? If one person takes 1 day to finish this wall, then in half a day, they can finish half of the wall. So if we have 2 people working on it, in half a day, we would have the entire wall finished. If we had 3 people, it would take 1/3 of a day. So see how this is going? The people, when you multiply the people by some number, then we divide the amount of time by that number as well. So when one quantity increases, the other decreases. So that's an inverse proportion. All right, proportions can also happen. Okay, this is kind of wacky. Proportions can happen with more than 2 quantities. The first problem involves just sorry, I should have that open at all times so I can see when someone messages me. Proportions can also happen with, okay, the first one deals with inverse proportions. We're going to tackle that together. If x and y are inversely proportional and x equals 10 when y is equal to 6, then what is x when y is equal to 4? All right, so this is kind of hard to wrap your head around, but let's just say that direct proportion means division. D, the direct and division, they both start with D. That's an easy way to remember it. But with inverse proportions, we're going to deal with multiplication instead. So xy is going to be equal to some number. And we don't know what that number is because we don't care. We're just going to relate the different values of xy to each other. Okay, so when x is 10 and y is 6, when x is 10, then y is equal to 6. When y is 4, what is x? So instead of setting up a fraction like we did with direct proportions, we're going to set up a multiplication instead. This is going to be 60 is equal to 4x. And then we divide by 4 on both sides, and we get x is equal to 15. All right. A big part of problem solving is also checking your work. So I'm gonna start to ask that you, before you send in answers, you check your work at least one time. And one way to do that with proportions is just to think about it. So when we have x equals 10, then y is going to be equal to 6. We know that these are inversely proportional. So when y decreases from 6 to 4, that means that x is going to increase. We increased from 10 to 15. So that sounds good, and that's our work checked. Another way of checking your work is just go through the problem again. All right. And 736, we're going to go through this last challenge problem. All right, given that x is directly proportional to y and to z, and is inversely proportional to w, and is equal to 4 when w is equal to 6, y is equal to 8, and z equals 5, then what is x when all the other 3 variables are there? All right, I'm going to give you guys time to think about this. If you have an answer, just direct message me. This is going to take a while though, because we have 4 variables instead of 2. Hmm, 40 minutes is not what I was expecting when I made these slides. Oh well. All right, so we're going to start solving this problem. Okay, we're going to learn about this concept later, but there's this concept in problem solving called casework. That's where you go through all the separate cases for something and try to work out each of them so that you can combine them at the end and get your final answer. And we're going to try like a somewhat variant of that. Okay, so right away, we know that we're looking for x. They tell us what x is proportional to, how it's proportional to it, and they finally ask us what x is when given with different numbers. Okay, so we're going to look at x, but with only one other variable. X is directly proportional to y. Then that means that we're dealing with division, so we're going to have x over y as our expression. X is also directly proportional to Z. We're going to have X divided by Z. But X is inversely proportional to W. So instead, we're going to have X times W because multiplication is inverse. Multiplication is inverse proportions. All right, and then we're going to essentially try and combine these. Not literally like we're going to add them or multiply them, but we're going to look at each case, X over Y and X over Z, and we're going to have X over YZ instead. And in the top, we're going to multiply X by W. So this is our expression. When we're solving proportions or ratios, what we want to do is generate some expression with what we're given. And then we're going to plug in values. When W is 6, Y is 8, and Z is 5. That little dot in the center means multiply. What is X? Oh, sorry. And is equal to 4. Oops, I should put 4 there, not X. What is X when W is equal to 4? And then we have X on the top. And then Y and Z, 10 times 9. All right, let's multiply everything else. We're going to have 24 over 40 is equal to 4x over 90. Okay, these are a bunch of weird numbers. But we can see that we can sort of simplify this. On the left, 24 and 40 share 2 as a factor. So we're going to change that to 12 over 20. But we can also change that. So this is going to be, sorry, we're going to divide by 2 on the numerator and the denominator again. So we're going to get 6 over 10. We're going to do that again because we see that 6 and 10 are still even, and we're going to get 3 over 5. Alternatively, you could have recognized that 24 and 40 are both divisible by 8, and you would have gotten 3 over 5 anyways. 4 over x, I believe those only share 2 as a factor, so 3 over 5 is going to be equal to 2x over 45. All right, we're going to cross multiply. 2x times 5 is 10x. And we're going to multiply 45 by 3. That's going to be 135. And we get as our answer that x is going to be equal to 13.5. Okay, sorry, I sort of botched that last one almost, but hopefully you guys understand. It's past 7:40 right now. I'm going to clear my work for a second. All right, percentage, we don't have time for that. Resources problem solving. Okay, actually I'm going to try and post, no, we can do this right now. Let's see, stop sharing. Okay, so there's this website, Art of Problem Solving. This, as it implies, this website is all about problem solving. They've got courses where you actually have to pay money to take the course, so much better than what we offer here, but ours is free, so I'm not sure. They have bookstores with books with a bunch of problems and doing things if you like to work at your own pace. They have also a bunch of games that you sometimes want to play. Alchemist for the win. They have a trainer for math counts competitions. They have some programming and physics courses if you're into those as well. That's pretty much my resources. Also Khan Academy. Hopefully you guys have already heard about that. Khan Academy doesn't really focus on problem solving, but it's a good way to review on specific topics. So if you wanted to learn about review ratios, percentages, proportions, they don't have an area for competition math, but I would check out just algebra because today was algebra, and we'll see. We talked about linear equations today and inequalities functions. We're going to all go over those later in the course. All right. And last slide. Okay, homework. I'm going to assign like a little bit of homework that's not mandatory, but it's just like some problems to help you with what we learned today in class. It's totally not mandatory, but it's really good if you want to get experience and help with doing problems. So I'm going to assign that in the Google Classroom. I'm sure the recording will also be posted. my email's here if you need help with homework or have feedback for the class. I really would love to have feedback about class and how I can improve it. For organization, Myri-Ed has their own website, myri.education@gmail.com. So that's like if you didn't like the format of the, not like the format. I'm actually not sure like what kind of complaints you'd have, like maybe timing or something. But yeah, that's pretty much it. Competition math, this is the class code. By the way, if you haven't joined that, you should probably join. Chat. There we go. That's the code to join this Google Classroom. I'm sure we'll send an email out next week. I'll try to get more people to come next week as well. And that is it. If anyone has any other questions, they're welcome to stay. I'm going to stop recording.